right. Hello, everyone. Welcome to the Natural View. We are here at SupplySide Global, Maggie and Todd, and we are at the fabulous Virun booth, this beautiful tree house. We're here with Bromley and Sara Fenn from Virun. Welcome, guys. So we're going to talk today about kind of some problem solving in the supplement space. And a problem that's gaining increasing awareness is oxidation and the impact on supplements. So can you talk us through the process of oxidation and what the problem is with supplements?
Yeah, I'll start with an introduction. And there's a lot of issues in the supplement industry that people aren't aware of at all, whether they're retailers, manufacturers, or consumers that don't realize they're having supplements that can be having very potentially dangerous effects on their health. And the whole point of having a supplement is to get healthier, not to compromise health. And we have an issue where many oils, whether they're omega-3s or cooking oils and olive oils and things like that, are actually oxidized before they even get bottled. And there are many reasons for that, whether it's a low-quality oil, whether they're heat processed or exposed to chemicals and other factors too, that could mean that because they're volatile, they oxidize and then they become inflammatory. They're then processed and on the shelf for the consumer, having negative inflammatory health effects. So that would be the initial kind of overview in that sense.
Any deeper dive on that, or we got it?
Yeah, so Sara, oxidized oils, Sara's exactly right. Everything she said leads to oxidation, cooking oils, heat, and processing. People storing things in their cabinet in clear bottles or not opaque bottles. We feel like oils in general, there is an issue with how I don't think the brands, manufacturers are taking the proper care in educating the consumer about these oils. And for sure, like we sell omega-3, and I understand omega-3 is obvious. It tastes fishy, so you know that the oil's oxidized. But people don't take that in consideration with other oils, like cooking oils. Your olive oil also can oxidize. It has a different off note. It might not be fishy. It might be more turpentine-ish is what I call it. And that is a sign of oxidation. Just the organoleptic, the flavor profile is different. But there's also oxidation forms. When oxidation occurs, you increase organoleptics and you increase certain chemistry that's in that cooking oil or the omega-3 oil, your soft gels, whatever. When that occurs, there's byproducts that are produced as a side reaction. And those byproducts are what is more concerning, because those byproducts are linked to, as Sara noted, inflammation. It's linked to cardiovascular disease, non-alcohol fatty liver disease.
What are some of the, like you touched on the additives that are in supplements and the purposes for those in terms of flavor masking or giving a better experience?
Yeah, so the go-to, which I believe you're referring to, is, okay, let's go into fish oil. Fish oil, everybody tastes them. They taste like orange. They use the citrus terpenes, orange, lime, and that's always been the gummies. They taste like orange, and that is to hide the oxidation. And everybody knows about the fish burps, but so the technique for masking is just adding flavor to cover it. It reminds me of like when my kids were younger, and I would ask my kids to clean their room, and I'd go in and I'm like, okay, it's clean. And then you would open up the closet, and then everything would fall out and give you a concussion as a hot box car, like hitting in the head or whatever. And it's the same thing with some of these other things. They're using these flavors to mask and hide the oxidation. And it doesn't need to be that way. There's techniques that you can use to prevent that oxidation and maintain stability so that you don't have to add a bunch of orange oil. And plus, omega-3 fish oil, alga oil, we use vegan alga oil, but we use fish oil as well. That's how fish get their DHA omega-3s from the algae they eat in the ocean. We use the one called schizochytrium. And so there's things you could do, and it's such an easy process stabilizing these oils. And same with cooking oils. I just think that people don't know, and they don't know to complain about it. It's not in the news. and people are consuming these oils that really are causing more damage than health benefits.
Yeah, so let's talk a little bit about some of those unintended issues. The consumer goes, buys these oils. What should they know about some of those unintended, consequences of consuming them? So you just mentioned they're bad for you. Talk a little bit more about that.
Yeah, one of the things with omega-3, for example, is fresh omega-3 oil can reverse fatty liver disease. Oxidized omega-3 can cause fatty liver disease in mice. So it really is having the opposite health impact. And I think from a consumer perspective, if you get a fishy burp after an omega-3 oil or capsule, it's gone off. You don't get a fishy burp when you eat fish. So obviously you shouldn't be paying a lot for oxidized fish oil. At the same time, if you then feel like joint pain because oxidized oils are so inflammatory, whether it's a cooking oil, like sunflower seed oil, rapeseed oil, things like that, the chemical structure of the polyunsaturated fats is so volatile that when you heat them or expose them to different chemicals, they change the structure and they become inflammatory in your arteries, and then that can lead to like cardiovascular health issues. But the first thing someone would notice is kind of weight gain, feeling a bit foggy, joint pain in particular would be almost immediate in that sense. And then just cutting out the bad oils and bad fats is a sure way to kind of reduce inflammation in the body. And most people notice that quite quickly. Other things with reading the label is that if the fat is solid at room temperature, and I'm more from a European sense, so like if it's like butter, lard, coconut oil, ghee, that means it's a saturated fat. So it's not as volatile to heat. So that means if it's solid at room temperature in the fridge, you can cook with it. It's pretty safe to kind of heat to high temperatures. If it's a liquid at room temperature, don't cook with it. Use it raw, like as a salad dressing or something like that. That's kind of the most like easy to understand where I would explain. Mm-hmm. And then when it comes to supplements and even fizzy drinks and processed foods, we haven't really talked about some of the preservatives like potassium sorbate, sodium benzoate that react with nitrates in water and food. Even if you don't have nitrates in the supplement, it's in drinking water. So inevitably they're going to mix together, react, and they can be mutagenic as well. So I would say steer clear of just too many additives in supplements, but potassium sorbate and sodium benzoate in particular, and they're ubiquitous in liquid supplements, fizzy drinks, and processed foods. And they're very dangerous as well. And Philip can explain exactly what happens in the process.
I'm glad you brought up the potassium sorbate and sodium benzoate in addition to the nitrites and the nitrates. And then you have the oils and oxidation and those producing byproducts that no one even knows about. But potassium sorbate, sodium benzoate, and nitrates, oxidation of oils, these are things when the companies that manufacture this stuff way back when they were approved and allowed to be grass, all this Maha stuff that's going on, they're talking about all the wrong issues, in my opinion. So these things are added. You test for them. It's like, wow, potassium sorbate, sodium benzoate. You know what? They prevent growth of pathogens and things that could be harmful. But then, and they test, and that's true. But then these bacteria and these pathogens aren't growing because there's not, aside from kill step and some other things, they're not growing because they're antimicrobial or whatever, preservative. They're preserving the product. But then what's happening in that matrix? If you were to like go into literally the movie The Matrix, into that matrix and be able to see what's happening in there chemistry wise and in reactions occurring over a shelf life of whatever, 6 months, a year, 2 years, what's happening is in there is these things are reacting with other stuff. Potassium sorbate reacts with vitamin C, causes carcinogenic material to form over time, and is linked to cancer. It's look it up. You can see published journals that show that. Some companies know not to add the things. Sodium benzoate converts and reacts and forms benzene. I think people know that more so than they do about the sorbate. Nitrites, nitrites, and nitrates, those react too, and they form all these carcinogenic materials and inflammation compounds. And the thing is, they test the product with these ingredients in there, showing they're safe, but they're not testing the byproducts. There's things that are formed over time that literally are causing disease. And no one's testing any of this stuff. And I don't understand. Maha and all those folks talking about how they need to get rid of FD&C colors and whatnot. Those are things that we're aware of. We see it. It's on the label. Guacamole turns brown. Hey, I'm not going to eat it. Well, what's happening in there that you can't see? And that's the stuff that I think not only the consumer should be focused on or understanding, but manufacturers, they can fix it. They know about it, and they're not fixing it because no one's complaining about it.
All right, so we've outlined the problems, and they seem pretty significant and slightly alarming, I will admit.
Right.
So, but you talked about that there are things manufacturers can do. So let's dive a little bit now into the solutions. Like if you want to be transparent, you want to be clean label, you don't want to sacrifice taste, what should the brands be focusing on? What should they be doing?
I would start with using fresh raw materials. So really checking where the raw materials are coming from and testing them. And then one of the things that we use is we use deionized water. So you're automatically reducing the chance of contamination. And instead of using preservatives, we use a bicarbonate of soda processing and then nitrogen flush the supplements in particular. So you're reducing the water activity and then there's less likely to have oxidation too. We use almond butter as a base to make, and it just makes things taste more delicious. And we don't use artificial preservatives or flavors. So we use real oils and extracts for flavoring. So you're getting something that tastes good, but it also is a lot better for you as well.
Yeah, Sara outlined it perfectly, that process flow. Use fresh materials. If you use DHA omega-3, it's processed direct. It's not too overly processed, running under CO2 extraction. We don't use solvents. We use CO2, which is a solvent, but CO2 is amazing. It's like a solvent, but it's a gas. It's almost like using helium to process things. And it evaporates, so it's a much more cleaner way of producing it, and it's natural. We do that. We have our bicarbonate downstream process. Think of baking soda in your fridge. It removes all the organoleptics and bad flavor in your refrigerator. Arm & Hammer has been making baking soda way back when for that same purpose. So we process using bicarbonate. It's patented. And nitrogen. Everything we do, we dose with liquid nitrogen, and we seal it and trap it in there. That removes dissolved oxygen and the matrix, the emulsion, the liquid, and then it removes oxygen in the headspace. And lastly, Sara mentioned we use deionization. Like, why is that important? Why use DI water? Why not RO water? RO water typically removes about 97% of metals. And the things that cause like cooking oils or DHA omega-3 to oxidize metals. Think of iron. Iron turns red, it rusts. If you got a big stainless steel plate of metal and you put it on the ocean, it's going to go from gray and turn red in the matter of days. So omega-3 and cooking oils do the same thing. They oxidize, they rust. And they do that in the presence of water, oxygen, and metal. So remove the metal. That protects the product from oxidation. Water, we reduce the water by using humectants like natural organic glycerin from coconut, and almond butter can act as a humectant. Kind of like a desiccant. It absorbs all the water, so there's no water in there. And then lastly, removing oxygen, using nitrogen to remove the oxygen. Remove oxygen, that is the catalyst. That's what causes the snowball effect that you just can't reverse. So you do those things, and packaging companies, cooking oil companies can do that. Some people know it. If you go to Kroger's or you go to your local grocery store, you will see the plastic bottles of olive oil, but then you see through it. You can see it's kind of green color, and so that's bad. You got UV light right above you. It's causing oxidation because light wavelengths catalyze the reaction. Kind of like when you're doing a chemistry reaction, you need a Bunsen burner, you need heat. Well, light is that source. But then you go and you look at the more expensive olive oils, they have a black bottle and they're protecting it from light. Some of them have reduced oxygen. Aerosol, I don't know much about this, but aerosol is probably a great way to use for cooking oils because you're spraying your avocado oil out of that aerosol container. It's not allowing air in. It's just exhausting the oil onto your cooking pan or whatever you're using. Soft gels, omega-3 soft gels, they come in HDPE bottles. We don't. We use PET bottles because PET doesn't allow oxygen permeation. So if you ever go to your hardware store or auto store or whatever, and you buy antifreeze or motor oil, you ever see those bottles that are kind of caved in on the side? They call it paneling. So that's HDPE. The reason why that happens is oxygen's permeating into your antifreeze or your oil, whatever it is, or shampoo bottle. And it's that oxygen allows all the reactions to occur, and it's reacting sometimes with that plastic. And it's causing that paneling because you're actually changing what's inside the product, and you're also changing the chemistry of the bottle itself. If you use PET, it's 100 times more stable as far as permeation goes, and that chemistry of that container changing. Also, you can dose nitrogen in there, and it holds it because it doesn't permeate here. And you can trap it in there. Our bottles will last 2 years, and you'll have the induction seal on top, that thing you peel off for safety and all that. We use it to hold the nitrogen in there, and we call it a trampoline effect. Like you can push on it, and that pressure is in there for 2 years minimum. And on the label, our products say refrigerate after opening. Even when you buy soft gels, they should say refrigerate after opening. People don't know they're taking their multivitamins and volatile compounds, as Sara mentioned earlier, and they're just putting it back in their cupboard next to their cooking oil, ironically.
Guilty.
Yeah.
I don't know.
Yeah, and it's I don't know how much it costs for just a few extra letters on print of your label. Just refrigerate after opening. Put your soft gels, your vitamins, everything. All my whole door is like filled with vitamins and things, but they're in the refrigerator. You put your food in there, why not put your vitamins in there? And especially oils and soft gels and fish oil. It's interesting because you go to the store and you get a salmon, it tastes fishy, or you make salmon, you make fish, mahi, tacos, and what do you do when you go home with your leftovers from whatever, and you put them in the refrigerator when you get home? But your soft gel's fish oil, it's still fish. We open them up, we take them, we just put it in the cupboard. Imagine if you put your fish in there.
And leave it there for months.
That's right. So there's things that you can do. Manufacturers can use PET. They can put nitrogen in there. They can induction seal it like we do to trap it in there. They could put refrigerate after opening on the bottle. But those are just some things, and probably many more things you can do.
I want to briefly touch on, you've mentioned a lot of processes, you've mentioned a lot of technology. When it comes to omega-3 specifically, is there anything Virun does technology-wise that we haven't touched on that you'd like to highlight?
I would say, so we touch base on, we use a bicarbonate, which is, again, baking soda. What it does is it binds to these things that are being produced as you're processing, and it binds to it and evaporates it out. Imagine like opening up a can of soda and then that gas comes out. Imagine it. And actually, when you can carbonated soda, they use nitrogen to prevent dissolved oxygen being trapped in the can to help the preservation of the can. So we take all this stuff in account when we're manufacturing, whereas I really don't think people even know this exists, or manufacturers know. The nitrogen, the deionized water to produce metals in there causing reaction. We have our Esolve. We have a vitamin E emulsifier that's natural. It's natural free tocopherol, and that helps as an antioxidant to keep things from reacting, and also helps as lipid. It helps produce liposomes and micelles. Micelles and liposomes emulsions, they help stabilize the product as well. And we have patents on that. And that's because you have oil and water, they will separate. You can emulsify them using surfactants. We don't do that. Think of Dawn soap. Dawn soap is a surfactant, goes clear in water, and that allows to remove oils off your dishes and things in your sink. We don't use those because they're synthetic. They use lauryl sulfates and sulfites and all that, and surfactants, polysorbates and whatnot. So we use almond butter to achieve liposomes and something called a cubisome, which is just a fancy word for fat in water. Mayonnaise, rice milk, these are all liposomes. We don't really promote liposomes. We don't like to talk about it because we think it's overhyped. Really, they're just food. It's food. We all consume liposomes. I mean, if you take almond butter and you make a peanut butter and jelly sandwich in there and you have some moisture combined to it, you're eating liposomes. If you eat Eggs Benedict and you have your hollandaise sauce on that, you're consuming liposomes. That yellow is the egg yolk, which contains phosphatidylcholine, which is a phospholipid used to make liposomes. And we like liposomes because they're just flavorful. but they also require a lot. They also obtain a lot of stability in emulsions. But again, we don't really market that because liposomes don't absorb when you ingest them. You go through micellization, it's the micelle that absorbs. And again, we just think it's kind of a little bit overhyped.
So let's touch on, I mean, you've outlined the issues. Can you go through any of the shelf life data or testing that supports all of this, the claim of
No, I think the first thing would be flavor, like the taste. That would be your first indication, the taste and the smell. And then if you have a negative or positive impact on your health that you actually feel after consuming something. And then there's loads of tests that can be done if...
That's right.
Yeah.
Yeah, Sara's right. And I'm glad you mentioned that because I would have not. It really is the indicator of something being stable is the taste. Does it taste good?
Mm-hmm.
I don't know how many times I've drank beverages. I've opened them up and you literally taste the yeast in them. They're not stable. And I don't think a lot of people pick up on that. It's like, this tastes like there's beer in here. That's not good. So the test methods we use to assure that they're stable, we put it in accelerated stability. So we run ICH guidelines. It's just a regulatory term for what you reference, whether it's FDA guidelines or ISO. There's all different types of guidelines. ICH guidelines, we have a stability chamber, kind of like an oven. And we run that about 41C, I think it's like 104 Fahrenheit. And we pump in there about 75% relative humidity. Here we have 0 because we're in Las Vegas right now. But you want heat and humidity will accelerate the stability of things. So like if I went in there and I was there for 9 weeks, I would be 18 months older. So you put it in there, we put it in there for about 12 weeks, which is 24 months equivalent of real-time stability. And then we pull it out, we taste it, as Sara noted, smell it. We look to see if the oil is separated out. If all those things are good, then we're good. And then we send out for testing. So we test purity of the active ingredients. If it's DHA omega-3, we run GC and make sure the DHA omega-3 is still in there from time 0, from the beginning to after the equivalent of 2 years stability. And we run GC. If you're wanting to test for that byproduct being produced, you really don't need to test that byproduct unless you get notes of fishiness or some off note, organoleptic just ain't right. Then you want to run GCMS or LCMS-MS, which is just fancy terms of instrumentation, HPLC, whatever. So you run GCMS or LCMS-MS, and then you test for the byproducts, the aldehydes, the ketones. Are any of these things produced? Whether you need to, really don't, because if it tastes fishy, they're in there, because that's exactly why it tastes fishy. But still, that would be the test method we would run, because we're just investigating why this occurred and what is it that's being formed. And if you look into it, like they're literally carcinogenic compounds that actually are linked to inflammation. So people are consuming cooking oils or taking these supplements that they're being told is good for their heart or lowers cholesterol, whatever, actually is causing non-alcoholic fatty liver disease or cardiovascular disease, inflammation. Yeah. I wish I didn't know. I drive my family completely crazy when we go out to dinner. Like, I'm like this, that. It's like, I went to a Mediterranean restaurant last week and came with vinaigrette. I'm like, is there a vinaigrette? Does it have olive oil in it? Like, we'll use olive oil mixed with canola oil. I'm like, why would you do that? I'll pay the extra, whatever, 5 cents, to put olive oil in there. Anyway, can you just give me olive oil and vinegar, and I know what I'm consuming, and I'll taste the olive oil. Like, does it taste like paint thinner, turpentine? It's like, no, it doesn't. You might know what I'm talking about when I say that. Olive oil should have more of a nutty, that flavor, even if it's bitter. That's great. That's the oleoropine, which is naturally occurring in olive oil. Is it black? I'm fine with that. That just means it's more quality. Is it green? I'm good with that. Yellow, a little bit questionable. Sure.
Yeah, interesting. Well, let's change it up a little bit and let's talk about delivery formats. So you guys have chosen to go with a smoothie style delivery format, correct? Versus a gummy or some other options. Can you talk a little bit about that choice? And,
Yeah, I'll start. We specialize in lipid emulsions and have been doing so for 23 years since Philip co-founded the company. So our expertise lies there. At the same time, the reason that I personally love, like the lipid emulsions, is because they make supplements more like food. So you're adding in the fats and the natural encapsulation. You don't need to add sugar and lots of additives and like pectins and thickeners that you do with gummies and other formats. So I think it's a much healthier way to create a supplement that resembles and behaves in a more similar way to food when you digest it without all the additives.
Absolutely. And gummies, they go through heat processing. The same, similar to how you make Jell-O. They're composed of gelatin, primarily cellulose. And going through that heat process, as we talked about earlier, can accelerate oxidation, especially with omega-3. But even oxidation and destabilizing vitamin D. So everybody's taking these vitamin D gummies. How do you know the vitamin D is still in there? Maybe it was when they processed it, and through regulation, they have overage, they detected it. But what about there's no nitrogen there? There's no that induction seal, HTP, oxygen going in there. How do you know that that's stable? When you buy it, like no one has an HPLC machine or has a microbiology lab in their house where they're testing to see if these things are forming, the byproducts are forming. Vitamin D is very difficult to test given the tolerance and low dose. You don't know what's in there a year later. So maybe it's good on day one, but is it good on day 300 or whatever? So we do all the different things that we talked about to assure that the product's stable over time. And another thing with gummies, to get a dose of efficacious dose of DHA omega-3, you got to eat like 4 or 5 of them. And collagen gummies, I don't even understand that one. But yeah, so with ours, like you take 1 pouch, you take 1 teaspoon or tablespoon of our emulsion, and that is all you have to take for the entire day. You don't have to eat 5 gummies. But the sachet format too became popular in Europe because that's where we started manufacturing the pouches initially and starting to become popular out here. And I think it's because of the smoothie. We were doing this 12 years ago in this type of format, and no one cared. Everybody wanted to take they're fine with their omega-3 tasting like oranges, oxidized oil mixed with orange flavor, and no one questioned it. And I think we talked about this last year, but fish don't taste like oranges. Oil should not taste like oranges. Oil should taste like fat, chocolate ice cream, salted caramel, whatever. So we use the almond butter with glycerin and natural cacao extract, vanilla, whatever, and you end up with these good flavored emulsions. And the pouch is good because it can push out product that has the texture and the viscosity of peanut butter or toothpaste, whereas it's hard when you're in a pourable bottle. You're in that whole Heinz ketchup bottle scenario where you're sticking a butter knife in there and try to extrapolate it. Mm-hmm. But yeah, that's primary reasons. Okay.
Yeah, I just want to add that the smoothie style supplements are so versatile. So you're literally getting like a functional food that kind of crosses between grocery and supplements, but you can have it straight from the sachet, add it to hot drinks, put it on ice cream. So it just makes it very easy for children to get their essential vitamins in a much more friendly way, but yet without the added sugars that you tend to get in the gummy formats.
Yeah, that's a great point and a great benefit for sure.
Right.
Yeah, and in Europe, they're actually taking our product and when you go to the checkout line and there's all your candy bars and that beef jerky, which I guess is healthy outside of the celery extract and the nitrates in there, which I've not seen one without that, by the way. But our stuff is starting to go into grocery, and we didn't decide that. They're coming to Sara and saying, hey, we want to put this into the grocery section, not as a supplement. And we are taken back by that. We were not expecting that. And they're taking our format with the sachet more as a yogurt or a Chobani and putting it into grocery. So you're getting your supplements as if they're food. And I think that's a trend that we're starting to see evolve right now, which is interesting.
Yeah, for sure. In fact, I was at a session yesterday hearing about some of the data about that. So I think we're definitely going to see more of that. So one final question to kind of drive home the point. We've talked about the problems. We've talked about solutions. We've talked about the gap in awareness of consumers, which for sure there is a gap there and something that needs to get out there more. But for the brands themselves, what are misconceptions that you would want to clear up like what's the awareness of the among brands, and what would you want to kind of drive home a final point for them?
I would say if they're going to do a health supplement, make sure it's actually healthy. I think it's so basic, but it's so overlooked. And I think through all the testing and just really thinking about all the additives that they're putting in, and especially if they're newly introduced into our diet, we don't know the contraindications and the byproducts that are created. So it's really like the closer you can bring a supplement or a food back to kind of a more natural food, the more likely it is to be healthier, because we're consuming things that our bodies have been consuming for thousands of years.
Yeah, I agree. And it helps me kind of understand and be able to elaborate on that. I think people need to understand why things that are in products, they hear that things are bad, but why are they need to be asking questions. Nitrites, nitrates, like why are these things bad? It's not the nitrites and the nitrates that are bad, because that helps preserve your bacon or whatever to last a little bit longer in your refrigerator. So it doesn't expire in 3 days, it expires in 3 weeks. But they're bad not because of what they are. Why nitrites and people don't want them in there is because they react, and the nitrites and nitrates start to go down over time and then form things that might kill you. So I'm exaggerating a little bit, but really they are linked to disease because of the byproduct. No one talks about that. I would almost want to see labels that say these products don't contain byproducts instead of the whole nitrates. And I think there needs to be more accountability on manufacturers who are selling these things and then actually putting celery extract to hide the fact that that's still nitrites and nitrates. And I think people in our position that are actually got products and are doing the right way and spending, it takes us almost 2 days to produce one batch of a product because of the care that it takes. And then every day after we do one step, and then we put it in the freezer, we put it in the refrigerator overnight, wait for it to set, and then pack it the next day using nitrogen and deionized water with UV sterilization at a complete loop. Because water goes bad really fast when you make it so pure. So you have to take a lot of extra care. If you let it sit for a few hours, you got micro issues. So yeah, I think the consumer needs to understand why is something bad, not just know that it's bad. Mm-hmm. And I think that manufacturers need to have more accountability. I don't know how that is. I wish Robert Kennedy Jr. would understand more of these things and just talk about removing FD&C red and everybody jumping on that and talking about it. He's right, and they're right about that, but there's so much more issues that people have absolutely no idea. FD&C red probably doesn't even absorb in your blood or anything. Who knows? Why is it bad? I don't know. But I could tell you these other things no one's talking about produce these byproducts, and they are bad for those reasons.
Yeah, it seems like you mentioned very early on in the discussion that manufacturers, because they're not getting asked about some of the other additives, then they're in there. From a consumer standpoint, that seems scary because you're right. There'll be something that's announced nitrates are bad. So then you go to the store and you look for, oh, this doesn't have nitrates, so therefore I'll buy it. Is there any way that you can ever envision the consumer being able to get ahead of it and walk into a store and not think, okay, I'm avoiding this, but there's probably underlying things. There's the next trick up someone's sleeve that I don't know about yet, that in 3 years, I'll be looking for a label that says no, whatever it is. So how do you even approach that as a consumer?
That's a tough one. I think it's so much to do with like regulation and accountability of brands. I think first we need laws to change about what is and isn't okay to put in food. It's quite different in Europe because we have much more stringent regulation. You have to prove it's safe, whereas I think here you've got to prove that it's dangerous in order for it to be removed. So I think first it's governance, and then brands following those guidelines. And then again, what Philip said about educating the consumer. Why is something bad? What else should we be looking out for? And consumers are increasingly educating themselves and being increasingly kind of critical, looking at labels. And I think from food to supplements to even fair trade, the consumer is thinking of like a healthier, more sustainable way forward. And that's just we're kind of slowly progressing that way.
Yeah, it is a problem. Everybody talks about seed oils. Like seed oils are bad. Avocado oil is good though. And it's been in a lot of people don't know avocado comes from the flesh. It doesn't come from that gigantic seed that's in the middle of it. It comes from the actual flesh of the avocado. But it's not and whatever, the podcast guy talking about seed oils and they're terrible. But why are they terrible? And then they start talking about solvents, all this. It goes through solvent distillation and reverse vacuum distillation where it's all evaporated out. So there's no solvents in there anymore. That's not why it's bad. The reason why it's bad is because of our diet. The reason why it's bad is everybody's consuming their French fries, their cooking oils. It's all canola. It's all sunflower seed oil. And they're consuming this. And they're not eating any fish or nothing. Everybody's eating meat and bison. And they're talking about that. It's like, what about salmon? Like, oh, it's got to be wild caught. It's like, I don't know. Like, wild caught salmon actually has more mercury than farm raised. So it's just all this stuff. People latch onto some trend that they hear on a podcast or whatever. And then it just gets exploited and everybody jumps on the bandwagon when they don't even know what they're talking about or why. Avocado oil and sunflower seed oil chemistry, the fatty acid profile, is almost exactly the same. It's just, you've heard of sunflower seed oil, high oleic acid. You use it for cooking oil. Well, guess what? Avocado oil is high oleic acid. The compound is no different from one oil to another. Olive oil is better. That is, anybody who says olive oil is better than seed oil or avocado, that's right. There's some omega-3 in there, omega-6, omega-9. It's more diverse. But the problem is American diet, even abroad, I shouldn't single out U.S. That's maybe a little bit more problem here. But the problem is everybody's consuming omega-6s and omega-9s and absolutely no omega-3. So you have all this stuff and not enough omega-3, and you need those to be balanced because those are diluting all the omega-3s. So you're not getting, even if you consume some, all that omega-3 is not going to help with your eye health, your brain health, heart health, lower cholesterol, because it's not getting there, because it's getting diluted from the omega-6 and omega-9. It's just meaningless. So it's really about, I think it's just society is just too cliquey about trends and not focused on why is this bad? Just it's bad because I heard it here, and I'm gonna follow what everybody else is saying. I don't know how to fix that. Here, maybe?
Well, I mean, you're starting the conversation, right?
Yeah.
We talked a little bit earlier, and you talked at other shows. So conversation's getting out there, and we'll continue to help spread the message
Absolutely.
and see where it goes.
Yep.
Yeah. So thank you guys.
Yeah.
Great
Thank you very much.
Thank
Always
you.
love the Virun booth.
Thanks.